Good morning, crowd. We're starting our second session. Asim?
Hello. Yeah, thank you. My name is Asim Chaudhary, and I am going to provide the updates on QS-Yang model. Right. Okay, so I'm going to cover these topics. Okay, next one, yeah. So there was an adoption call in version 7 of the model. We got some reasonable set of comments. We had replied to some of the comments. We answered some of the comments. We clarified some of the comments. Rest of the comments we are able to incorporate, and based on that, we were able to publish version 10 of the model. Next slide. Thank you. So basically, some of the comments had been regarding the references. There were some missing references. There were some incorrect references. So, for example, we added reference for Yang 1.1 into the draft. We added reference for the imported modules. Also, some of the Yang nodes, we provided a specific reference from the work which had been done in the past in the various RFCs. For example, for Polyser 1 rate 3 color and 2 rate 3 color, we were able to provide reference for RFC 2697 and 2698. Similarly, for queues and scheduler, we were able to provide reference through RFC 3289. Similarly, we added reference for Yang tree diagrams, which is RFC 8340. As well as we added reference for NMDA architecture. Next slide. All right, so some of the comments had been regarding the dates. The dates were either in some cases not updated. And so what we updated the dates for copyright information, we updated the dates for revision of the various modules. Also, we added section for INA consideration. We provided some editorial note in the introduction section, detailing that this particular, once the RFC is created, then remove this particular section or update the RFC number accordingly. Next slide. Also, when we were going through, when we were reviewing the draft ourselves, we figured out that in the diffser model, we need to provide further restriction into in what cases we will be able to configure diffser module. And that will be based on the diffser policy types. So accordingly, we added a when statement for it. So to summarize the draft, we have created a basic framework of QS as in classifier module. We have action module, policy module, and target module. And these are the base modules. Based on these base modules, we have created set of derived modules, which are diffser module. And diffser include match and action related to diffser. But it takes those matches and action and combine them with the base framework of policy and classifier and create a policy out of it. Similarly, we have created a derived module of queuing policy, which actually work on the metadata information, and then we are able to configure the queuing parameters. Similarly, for schedulers, we have provided the actions for scheduling Also, the references have been provided from the previous RFCs for that. Also, this model is very, very adaptable to any vendor requirements and any vendor, because the constructs are so different across vendors for QS. So they may be able to, use various match and action and able to stitch with the base framework of QS and can create their own set of model also. And they can keep adding a lot of features. They can keep adding a lot of match and action when there's a requirement for so. Next slide. Okay, as a next step, we expect any further comment. We will be looking for any further comment from this community. Also, vendor prototyping is in progress in some cases. Also, to be realistic, unless until this is adopted and become a working group document, vendor will not invest that much to actually implement the draft. So once it becomes a working document, then vendor will go ahead and implement the draft. Yeah, okay, let me finish the last point also. So currently, it is in candidate for working group adoption. Please provide your opinion on that. Thanks. Yes.
Dan Bogdanovic. So this document has been bounced around now for 7 years, 8 years?
Not really, few years. We started, I think, in 2015.
Even before that.
Yeah, because
even before that, because there was a previous version of that document that was then restarted. It was restarted in 2014 beginning of 2014 because I was one of the authors on that.
Right, you were part of the draft.
Yes.
Exactly.
So, and we are still trying to issue the first version of that document. Get
okay.
the first document, to start work.
So I think there's a good reason for that, though. This is quite difficult to standardize these QoS models. So it's not a coincidence, but yes, it could move faster. But what is your specific point?
Well, the specific point here is that we are trying to match on all the functionalities instead of saying and abstracting, saying these are the basics how QoS is working. These are the basic elements, and then different characteristics of those elements can be specified afterwards. But right now we still don't have a common syntax how to specify, QoS in the systems.
Okay, so
which of the schools of thought will we go? Will we go with the vendor C school of thought or vendor J school of thought or something?
No,
in between?
I think this has been clarified in the past presentations that the way we proceeded and we understood that will be accepted by all is when we have a kind of a superset of the model, and that not only is the operational excellence in many cases, but also it allows many vendors to implement in a couple of ways the same configuration. In fact, some of the vendors do allow the configuration that in a multiple way to ease the operational excellence. So yeah, means maybe I am missing the point here. Means what is the specific question here?
You're trying to overspecify too many things in a single draft without starting just to have a basic syntax that could be implemented, then C, and then adding, the additional QoS features on top of that. For example, like their buffers, everybody's using buffers and queues. Specify them, describe them, and then different types of buffering and queuing mechanisms depending on what vendor supports which version can be then added and extended.
Keep extending, yeah, means basically the queue schedulers and polisher are the basics of the QoS. So if we don't have, agreement on that, then it's hard to say that we have the QoS model. So we have to have agreement on all those aspects, the basic aspect of QoS.
Rob Wilson, Cisco. So I was really surprised to see this hasn't been adopted yet. From my point of view, I think it's fairly obvious that IETF does want to do a QoS model. We've been working on this for a long time and it's changing. I'm not sure we need perfection here. We need to get something out and shipped and we can extend it over time. So I I'd be very keen to see this adopted as it is. There's been a lot of time spent on it, and then refine it a little bit as we go, but try and actually get this out the door. Because we've got lots of other Yang models out there, and people want to use these, or should be wanting to use them. So we want to try and push this along if we can.
Okay, so, yeah, means the model has been stable for some time now. It just said, we had been requesting for more and more comments so that we can incorporate those. There was a version 7, there was an adoption call. We got some comments regarding the, mainly regarding the format and some of the correction to be done in the drafts, which we have done. But other than that, yeah, the model has been stable for some time.
Okay, thanks.
Stefan from Orange. I have a similar comment as Dan had about not the complexity, but the level of details in terms of scheduling, which is currently in the document, because especially the scheduling is something which is really hardware dependent. And you may not be able to do exactly the same thing and express it at least in the same way on one hardware or the other. So I'm really happy to see that you have some vendors that are trying to prototype this model. And I will be really happy to see the outcomes of this prototyping, if it's something that which is really feasible in terms of modeling or not.
Okay, so there had been some reference in the past, in the particularly the RFC 3289, where actually described about the scheduling parameters and all. So we have referred that to model this one. So and we have similarity across vendors to implement those scheduling, the basic
There are
scheduling.
some similarities, but it's not exactly the same. And today we are already facing some issues when we are moving from one platform to the other to re-express our cost model, because sometimes it's completely different. And we cannot really do exactly the same thing.
So, okay, so has to understand the specifics of that. But as we have debated across vendors, we do have a similar set of parameters when it comes to scheduling and queuing.
AC Linda, Cisco Systems. In defense of this, I haven't reviewed the latest version, but I did review one a couple of years, at least year and a half ago or something, of this model. And it's not, one of the real problems is chip designers have had no motivation to have any commonality in their QoS, the way it's attached. And at one time I worked on trying to unify the CLI. This was years ago, for different line cards families in the same chassis, but it was just about, it was a hard problem to find a minimum subset, and you really couldn't get something that one size fits all for it.
Exactly, means it's not easy problem to solve, but over a period of time we have debated a lot, and we have come up with a model which actually works for all. And we see that all the vendors will be able to adopt the way we have designed it right now. And so I'm pretty confident that any vendor will be able to use this model to configure their device. Even though, for all the, even for a single vendor, there will be differences for QoS based on the platforms and all. But they still, provide the common CLI across it. And so we have merged all them together. And I think all the vendors should be able to provide. We are pretty confident about that.
So in terms of this document, we already started an adoption call back in December, I think.
Exactly.
And a lot of this, the changes you've applied are responses to that and so on, and other feedback. So, I mean, we're planning to adopt this. We've gotten a lot of feedback that this approach possibly isn't as useful as another approach, but does anyone actually have an objection to going ahead and, adopting this as a working group document, polishing it off and publishing it as, this isn't a working group last call, but in general, our intention would be to adopt it, finish it off, publish it. Does that produce any damage? Any objections to that?
I'm very supportive to adopt it as a working group document. I just consider this document too complex. That's one part. And if we will try to put some of the other related models to work with this model, we will run into challenges.
Okay, but do you see this as a good basis to start with to adopt and,
I would cut down significant amounts of document, but that's my personal opinion.
okay.
So would anyone oppose to adopt this work here and start refining it, iterating through? Sounds good. So we'll continue with the adoption process, and there are a bunch of warnings. Please fix them before.
Okay.
Thank you.
Thank you.
Let me just double check the schedule here. Yeah, next up is Dan Bogdanovich.
Thank you. Hi. So we've been working, some of us, on automation for multiple years and on the management. And as we are implementing some of the concepts, we are seeing some of the problems that we are running into it. And some of, okay. So I really, when I saw this on Twitter, I really liked it because we are putting the cart in front of the horse. There are some changes coming in the networking that will require some significantly different an approach to how we are doing network automation. But we are still using some of, in my opinion, concepts that are too much device related and not much service related. Why I'm saying this? We are seeing a large increase in routing endpoints in networks. Today, large networks will have 6,000, 7,000 routing points. We are talking to service providers that are planning to increase their networks to 120 plus thousand endpoints. AT&T publicly announced they're adding 60,000 routing points in their network. And how we are doing network management today, I don't see how we can effectively scale that. Because the traditional network management, it is very much focused on a single device. You're building up from multiple device configurations, you're building up a service. And the larger the network is, the harder it will be harder to do that as well. It will take longer to provision new services across significantly larger network than what we have today. We are trying to move away from a human interface to a machine interface, but some of the content that is being provided through the human interface, we are just translating it directly into a machine interface, and we are missing some abstractions. We are trying to do that with the models, but still models are too much. I would just point out to the QoS, which in my opinion is too, the only reason why I'm pointing it out because it was the last one mentioned just before my presentation. But it is, instead of trying to abstract actions and saying this is the abstracted way how we can do it and it can be implemented across multiple different architectures, we are trying to cram all the architectures into one model, and then we are ending up with something pretty complex that is not helping us moving forward. As well, we are not improving the programmable capabilities of the network that we are trying to do. I put in here a couple of, essentially, these are descriptions, actually definitions, but the key thing is that in the automation, with minimal or no human intervention, there are few private enterprise operators that are very good at doing this, but many people of them, they're still relying on the CLI and on the human operators. The idea is that we have to, if we want really to scale those networks and provide those new services, we have to rethink, some of the management, how it's done, even, some of the tools, because the idea is, look, you have to do it from a service perspective and from a service going down, essentially turn it upside down. This brings us to the API management, approach. And we have today some tools and protocols that are there. Some of them are developed within the IETF community. Some of them are being done by the vendors. Some of them are being done by the consortiums, plus open source. They're all helping us rethink how we are doing the automation and seeing how we are, how we can move forward in order to address the new requirements. But some of us also have to switch, the network engineers, we have to switch our thinking and start thinking more in doing programs. I will show this later. There are no conditional loops in the configurational data that we are doing. It would be very nice to see, how can we add unit tests for certain functionalities as a network engineer? And this is one part that we have to start thinking more and trying to adopt more software development techniques instead of what we were doing through different vendors' provisioning processes that were mainly saying, here's the business logic that want to be executed on the device, but I cannot put any conditional statements inside that provisioning information. With the API definition requirements, we are defining and what we are doing here at the IETF with the data models, we are essentially defining and we are describing different levels of functionalities that are available in the devices as well. In the networks, we are talking about what operations can we do. We are deciding how we can, send the data back and forth, that we can understand it, that we have standardized it. Because most of those things which are well known within the software development in the networking until very recently was very much on its own, and our best tool was tickle and expect. And we all know the pains that was causing us that. The data models, they are, so again, they are vendor models, there are some community models. I'm just building, going through all of that, just giving you a brief overview. But some of the models, I'm saying, we have to provide better abstractions. If we can say there are common functionalities that every single vendor is using, but how those functionalities are implemented should be abstracted away. We should not continue pushing up those implementation details into the higher levels through the data models. If we continue doing that, we will not be able to scale the management forward, and then all the efforts that we are doing will be, I don't want to say in vain, but I'm going to say it. So the transfer protocols, there are multiple of them. Everybody can decide which one they want to use. But one of the things which I'm a little bit concerned is that gRPC is becoming de facto standard for telemetry. gRPC is more or less owned by a vendor, well, by a single enterprise. And not what we need, all of us commonly, might be good for us, what might be good for that enterprise. And seeing more and more requirements that saying, we want, gRPC, GNMI support is, it's a nice thing to hear because they're providing some good mechanisms there, a good framework. On the other hand, I'm also hearing some concerns that framework is not sufficient enough for what some other operators, network operators, would like to do. So if we are looking at the network device configuration and management APIs, we have device resource and network functions that should be used for high-level data models. And at the NetMod working group, we are trying to define how can we build up packages that to provide the abstractions for different functionalities and systems that you want to build in order to ease the management and provide common schemas to the higher level ones. The point there is the young data model and the young language is a common language that is adopted. Some people prefer protobuf over Yang, but majority of the industry is settling down on Yang. The bad part of that Yang is it's too much tied to 2 out of 3 available transport protocols that are in use widely today. And us working on trying to say, hey, there is another framework that is being de facto standard, but Yang is a standard, and those 2 things are incompatible, is a problem that needs to be solving, that we should start thinking about that. Because the more we will grow apart, the harder it will be to come together, and we will run again into a management problem. Forgot to mention at the beginning, there is I heard it from several people, that the golden standard for network management was the Wellfleet Frame Relay Network Management Suite. And many operators are remembering how nicely it was done. They're saying, if you can provide us something like that, we will love to buy your product, because we needed a very small number of operators for us to manage a continental scale network. And we have to do that, but we have to be sometimes a little bit more open and saying, let's forget about the implementation details and decide on the functional details in order to move it forward, and make sure that what the industry is doing, that we are, aligning the common interest across that, and making sure that we are not letting certain things out, because it can, really hurt us. This is a example of a open config device model. And the reason why I'm, putting it out, this is done by a consortium, and they put in functionalities in there that they really needed. There are things that could be, extended. There are things in there that are, missing, but there are also things that are there that could be used. My main issue there is, it's a device model. Where is the next one? The service models on top of that. In the IETF, we have 2 service models that we have worked so far. It's the L2SM and L3SM. We need many other service models that can sit, on top of the device models and build up. If you look again into the open config gRPC interfaces, and I'm going here a little bit more with gRPC interfaces, since last time they presented at the IETF, there has been an evolution, and some of the concepts that we did in the IETF and dropped, they picked them up and or they came with their own ideas that were similar to our ideas and expanded that. One of the interesting interfaces that they added is the grib. This is, if some people might remember the I2RS, the original ideas of the I2RS and grib have certain things in common. But then the very interesting part is how they're integrating with the GNMI and getting the information about the informational state they can use for certain, other operations. And this is a nice example how they were building on top of the abstractions and putting, into a pretty common frame, a foundational framework that works well if you want to build different applications on top of that. So quickly, why I like GNMI, it gives you essentially capabilities. So you're getting, okay, give me the capabilities, what are there, I can get and set on them, and I can subscribe. And I like the way how their subscription stream works. I think that some of our subscription frameworks that we have available today have things missing. I also don't think, I think they're too heavy for the devices. And we should try to see what can be changed and what can be adapted from some of the other frameworks. Because one thing, what I really love about the GNMI is for the telemetry. And you can decide, okay, here's my, I want to subscribe, and this is the path to the path element for which data information I want to get. This is interesting because you can create telemetry, you can create data collection subscriptions for a specific service and get data for that service. That means when I write an application that provisions a service, I can subscribe only to that service relevant information and use that as certain event triggers that can provide the corrective actions that can be the input for my conditional statements in my service provisioning in my service provisioning logic. So do we have the right tools today? Yes and no. We have the right ideas. Some of our implementations could be better. You know, I'm guilty as charged. I've been working on that for years, and you know, we are learning as we are moving forward. But I will make a call out that us vendors are not the best people to talk to and rely on us on how to do operations. I've been a vendor my whole life. So, you know, this is the one part that, but we also know how to do certain abstractions, and we should do that, forget the implementation details, focus on the functionalities and saying, this is what we can do as a vendor. This is what we can get input from the service, you know, from the network operators, and use the input from the network operators to refine the network functions that we are providing to them to build the network services. The service models, as mentioned, you know, they are two of them, open config. I will say that they only define, you know, models at the device level, and growing the network just based on the device level will not scale. We will run into many problems if we will, you know, when we see like a 10 or 20x increase in size of our networks, the way how we are managing, you know, that today. And the many network operators have their own proprietary tools that they are creating in order, you know, to manage the services. This is how they're managing the network, how they're creating the value, and this is how they are at the end making money, making profits. If we can help them by providing them better tools for them to create the higher, you know, values, that will, you know, be also better for our industry in general. So the question is, could we use any reasonable pattern to design and automate networking service? This is something that we should be asking us when we are working on any of the standards that we are working on. So we try to classify certain things, you know, in the IETF, but yesterday during the first working group session, the presentation from Reza and Nokia, he was mainly talking about translation of a business service into lower layers. I will say that again, we are not the right community to define the business services and interfaces to the business services, but we can help them to define an interface between the business service and the network service, and then, you know, going down into how the network service is being decomposed into multiple network functions based on the characteristics that the customer is asking for and what the network operator currently supports. For the network service automation, you always have essentially three heads. One of them is a business user. I like to say this is our good old known PLM. Here they have to define the use cases, tell us, you know, what use cases have to be defined. And the network operator knows about troubleshooting, operations, provisioning, and then we have a network developer. When I talk to some of the VARs and SIs today, they're saying we have 2,000 CCIEs and 1,800 JNCIEs. Great. But those guys cannot really, they are good as network developers. The question is how many of them are as a network operators, and how many of them will be really good at translating the business user requirements into, you know, into the lower layers. So if you look at the traditional network service orchestration approach, you still have a network operator that is following the alarms and then executing certain predetermined actions. When I was working for a large vendor, they had an SDK. One of the biggest applications they were using for the SDK was preset commands that the network operator was executing based on the alarms. They were creating custom CLI for a different level of an operator. I'm asking, why do you need that operator in there to execute on that? Create a loop, control loop, and let that automate that and let that operator do something more valuable. But our tools are not there yet, because if we want to build And as an application, the network developer has to listen to the business guy. They have to look at the operators guys and say, these are my business, technical, and operational requirements, and I will put that together into a single network application. I will be using the well-known procedures of software development, where I can unit test my functions, I can unit test my service, I can do different types of testing, functional testing on that, and I can run that application multiple times. I will have the predictable results. When we are putting in different configurations, we are still trying to figure out what is the state. We are not always sure that the state on the network will be what we were really putting in. And if we would go from a top-down perspective, saying this is the predicted state, we can then compare what is the state on each device and try to do the corrective actions. And that would be the first part, is that we have to, saying we are having a set of APIs from our devices that are being, streamed upstream, that are being, from a network service instance being pushed down, and they're being, essentially streamed up for the monitoring, of the device resources. This would be the step one, when we are starting to add conditions on the network to be tested and verified, where our service logic base is checking on the functions that we have invoked, if we build the right service, and we can then provide another API to a high-level application to be consumed by that. If we can achieve that today, there are certain operators and enterprises that are building on that. They have experience on that, and I would be happy to work on such architectures descriptions just as in informational documents with the other people. But now, where we really have to start going as a next step is deciding, hey, we have a distributed device management platform, and I really want to have a streaming events bus that is providing the operational and provisional interface in one. I'm just passing into the stream, and that stream will push the data to all the devices for the service. So instead of being on the device base, I have a service level, and that service level, because the device is configured for certain types of events, it will receive the provisioning information, but it's also sent back the operational data. For that, there is a pretty good framework out there that is done by a vendor, and there are certain things that I would like to see in that framework to be expanded and extended, and maybe even standardized, because this would be very helpful. And then we can have, for the configuration actions as well for the monitoring actions, a single API. We can have a single common data model for both of them, which would make something, because one of our biggest problems is translation between the operational model and the configurational model, and trying to figure out what does this operational model mean in configurational terms. This should, be able to simplify the actions that we are trying to do. And then as the last iteration would be that instead of having, separate configurational and operational parts, we would just have a network service instance that would be using the underlying SDK. And instead of being an expert in CLI, you would say, oh, this is a new library that I have to learn in order to be able to provision this new service. And writing a new application would be network independent as well as a vendor independent, because you're talking about the abstractions and saying, look, for me to do a filter, I have to have a match condition, I have to have an action on top of that, and I will be learning what different types of actions and match and action conditions I have available in order to execute on that. I can find out from the network what is available, what is not available, are there resources, are there no resources, and based on that make a decision. Can something like that be deployed across the service topology or not? These days, why do we still have to use rollback? And then the question is, what is the state across my network after I did the rollback? And that would be the end of the application, the presentation. And if you have any questions, I welcome them.
Benoit, so thanks, Jan, for this. So it's great. Now, what I'm missing is, okay, what are the top 3 things we should be doing in this community to go there? Top 3 things. What are the top 3 things we should be doing now to get there in this community?
I would welcome so I will go back to QoS and ACO to have it better abstracted, be less implementation detailed. So provide better abstractions throughout the Yang models. Try to reach out, because my big worry is telemetry, and GNMI is a really good telemetry framework. What we are doing here needs a lot of work, and I don't think that it can scale to what we need, and try to re-engage the GNMI in order to get it done. So, but then also I would ask that vendor to be sometimes a little bit more open to our input as well, what we are proposing back, because we also have our own reasons why we need certain things that might be different, from that vendor. So I will say again, we need better abstractions for devices, for the network functions, devices, network functions, and to a certain extent for network services.
Robert and Cisco. So I liked your presentation, it was good. I think that I agree that it would be useful to have an information draft documenting how to use some of this and do the lifecycle management through Yang. And that's something I think that'd be greatly beneficial. And I have an interest in that sort of stuff as well. One question on this particular slide here is, what do you see the API as between the operators and the services? Is that something that's written in Yang, or is that a programmatic interface in some particular language?
It's programmatic interfaces, whichever language you prefer and you like to use.
Okay, so who writes that SDK and who chooses that language? So
the language, you have frameworks that can, once you write the definition, can give you library in many different languages.
Okay.
And it's a question now how you can get the data model be translated into the language. So I will not go into the specific different frameworks that are providing you that functionality, but that would, there are frameworks out there that can be used. And again, it would be easier, I will come down to that. If Yang would be a little bit more independent to be able to write some of those translations between Yang and some of the other frameworks without having the other transport protocol restrictions, what we have, we could, work from there. So this is another part that we could, be working as a community, because Yang is being adopted and it's a useful tool that we can use, but we have to evolve. I would like to see more about Yang Next, what we could do. There was Yang Next, and then suddenly it disappeared. It vanished. So I don't want to be very much per se on a language specific. I say this is a common interface that we can use in order to provide. There can be variants of the features that are supported within that, but they share a common syntax.
Okay, so does that mean really that you need to translate Yang into something like OpenAPI or Swagger or something, and then that can be used to generate whatever language bindings you want?
Yeah.
Okay.
I have two questions.
Name, please.
This is Liao from Soleo, from North American. We support Department of Defense. I have two questions. One question is, where's your northbound interface in this architecture? And the second question is regarding this streaming event bus. So it's bus, you are talking about pops up, which is asynchronous communication. For telemetry, maybe fine, but for the provisioning, how do you guarantee, what your present will be immediately, being committed, it's working? Because pops up is asynchronous, not necessarily what you intend to provision will be provisioned. So there may be delay.
Okay, so I have a question now. First, you asked where's the northbound interface, where the north and southbound interfaces are? And then the second question is, how do you guarantee the network that the provisioning information was has been provisioned across the service that you desired? Yeah. So on the northbound and southbound interface, this is relative, where you're putting in. In this case, yeah, southbound, I should have put that there, an API, and say this is my API to the devices. And think about devices are the physical layer that are doing the packet forwarding. Then you have the device management platform, is where you're abstracting the devices in a set of functions and the resources that they are using. As well, you are providing, the message bus that has the provisioning and the operational data that you can subscribe to, that you can, collect and send the data to. So you have here multiple northbound and southbound interfaces. I am not hung up very much on that, what framework it is. I just want to define what are those data models, what are the schemas for those interfaces. For what the actual implementation will it be on that part, what today might be young, tomorrow might be, protobufs, day after tomorrow might be, shameless, plug voltabufs, whatever, it doesn't matter. And if we can agree on the general network management architecture, that would help us with the next step forward. And then you're asking me, how can I guarantee that my provisioning was done correctly across the network, across the service topology? So I can, when I'm writing software, I can always do unit test and verify that I have the outcome. Today, when I want to write unit test, the operational model and the provisional model are different, and I have to do transformation with the data and making sure, oh, was this really what I meant? Does this, operational model really translates correctly into my provisioning model, and vice versa? So this is one of the problems that we have today when we are doing that. If you can remove some of those abstractions in between, then you can start doing unit testing and making sure through either you can then decide does it have to be an end function, or it has to be an end function, or how will you, combine of each of those unit tests that are going across the network, what would be the final outcome? This is what the network operator can decide based on their own internal policies.
So in the synchronized communication, basically you send a request, you respond, you expect come back within a few seconds. But for asynchronous bus, you send something, what you respond may come back hour later. So there's no guarantee with service bus. That's a big difference. So for telemetry, probably that's fine. But for query,
hold on. So now, please stay there. I just want to make sure that I understood. So first of all, you said you're interested in if the data is correctly synchronized.
So the synchronized, basically like if you write your software, right? For synchronized communication means you send a request, your response will come back within a second. You expect it to come back with a very short time window. But if you utilize the service bus, which means it's a pub subscription model, which means your communication is asynchronized. You send a request, your response may come back hours later. So you're not guaranteed to come back within a few seconds.
So these days, sometimes to get the wire, get the state on the wire takes 20 minutes. So a few seconds, I would see that as quite a good of improvement. I mean, if I understood your question, is today we have a problem that, different devices take different times in order to get, on the same, to get the same provisioning information. Same network state.
My point is a bus may not be suitable for provisioning type of traffic. It's good for telemetrics, but may not be good for provisioning type of traffic.
Then can I try to answer his question? So
Name.
For you, if in this case, I'm Xifeng Liu from Water Networks. So for the scenario you described, it's pretty much like a notification. It's other kind of notification, not a telemetry. So for that kind of notification, all the common management protocols already support that. NetConf has notification, and so you can get the notification that way.
Okay, Hao Mian from Huawei. I have two questions for clarifications. The first one is on the slides. You have two platforms, and both of them are marked as distributed here. So from the service one, we have multiple instances and it looks like a distributed system, but the bottom one, we call it a device management system and it looks like it should be centralized. Would you mind explaining why you think this is distributed system?
Devices in general will be,
No.
and then if I want to create a single centralized management platform,
Right.
the question is how to scale it. And if the idea there is that you want to keep up certain latency requirements for the certain devices that you're abstracting in a geographical area, you could, using today's technology, can build a single device management platform for the whole US, for the whole North America. But how much does it make sense because of the latency that you will be seeing in order to communicate those devices collected? So if you are doing some hierarchical management platform that is distributed, you can get to certain performances that you need in order to do the right provisioning.
Okay, so there can also be multiple platforms on the same level, and do they talk with each other, or how they interact? I mean, on the scalability perspective, okay, it is okay to have multiple platforms on the same hierarchy.
So there are different schools of thought on that, and this is so if I would, let's say example, how do I want to do database sharding and how do I want to implement that? That is a question how different people will do it, and different people might have different ways of implementing that, but they can come up to the same result.
Okay, my second question would be, in this presentation you talk about a lot about the network service, and if I understand correctly, the service is something that exists in the service management platform and something beyond it for the user plane. I also noticed that in this slide and some other previous slides, the term service is missed in the kind of device management platform. So are you implying that the service, say, the management platform is not aware of this network service, or?
So the device management platform and the service platforms are different. And I was talking here more about network management than specific services. I just see it as build-ups on one on top of the other, because the network operator, for them, services are revenue generating, and the control plane, the physical layer, is a cost center. So they would be focused mainly on services, how they can provision the services faster with more ease in order to satisfy the customer demands, and making sure that the underlying operational infrastructure is being managed most efficiently.
Okay, so on the API here, we basically focus more on the resource rather than the service, right?
It's capabilities and resources. They are very tightly coupled together.
Okay.
And so just the last two questioners, and we're closing the line here and try to wrap it up in about 5 minutes.
Stefan Kowski from Orange. I have a very, very open question, and I don't have any strong opinion about it. Let's focus in 10 or 20 years, okay? Abstraction are really something which is required, especially from provisioning, because it will speed up how we are creating services and so on. But now, if we are focusing on really network operations, don't you think that at least on the operator side, people may lose some skills and will not understand anymore how things are really working if they are only manipulating abstraction?
I can go back with the same with the computer science. Are we losing, that people are only learning higher level languages? There will be people who will want to understand the system throughout, that would like to understand how packet pipeline is working, but I don't see that within a large enterprise like yours, you will have 5,000 people that are really interested in knowing how packet pipeline creation is working. You might be interested. You might really want to dig that and understand that. There will be people who really would like to know that, and they will dig into it. They will be able to go through those, but in order sometimes to understand how things are working. If I go back to the days when I went to school and, I had like a piggy board, and in order to do certain functions and the programming, I had to shortcut them in order to get there. And to understand how high level concepts are was a pretty tough journey. And sometimes seeing, and some of the new concepts, you see the abstractions, then you go down, understanding it, and you're learning some new stuff. So there is something to be said for both.
Yeah, because I'm still not concerned or worried, but I have some question about, in 20 years, if, for example, I have a packet which is stuck in one queue in one specific chip of my box, will still I be able to know it?
Yeah, well, this is a good beer buff discussion.
Robert and Cisco. So I just wanted to comment on, there's some discussion earlier on about synchronous versus asynchronous programming models for doing configuration. I'm a big fan of doing this in an asynchronous way, where you push the configuration down and you assume that the device will take some amount of time to apply that configuration. And not only that, that if the configuration set is large, different parts of that configuration will be applied over a period of time. So I think there's a lot of benefits of being able to monitor and get telemetry data back up of what the configuration changes are, so you can actually see what the device is doing over that period of time, rather than getting a snapshot after 20 minutes. Now it's all done, and in that window you don't really know what it's doing. So that's one benefit of doing this in a synchronous way. Another one is, if you want to be modifying your devices at a relatively high frequency, you don't want to be blocking and waiting for each device to reply back before you move on to the next one.
On certain things, you have to do that. There are certain provisioning actions that require you to do that.
Yes, I agree. But I wonder whether those provisioning actions that should be controlled by the controller that does the sequencing and not the devices themselves.
Yeah. Thank you.
I'll add one comment. Dealing with this pretty much on a daily basis, I would second, you have to be asynchronous. Networking is a distributed system. You don't want to deal with slow readers, slow writers. You have to do this. We cannot go into synchronous mode with thousands of devices. You'll be locking forever. So just personal comment.
So next up is Oscar Gonzalez de Dios. No? Okay. Oh, she's presenting remotely? Oh, there we go, yes, okay. Oscar, we cannot hear you. Do we need to?
Okay, can you hear me now?
Yes, we can hear you.
Oh, okay. I think I am muted. I just needed to press the blue button, the blue mic button. Okay, so thank you very much, guys. It's a pity not to be with you today, but fortunately we have these remote facilities to present. So I think this, the idea today is to present you the Layer 3 VPN network model that we have recently submitted together with some other operators. And there was a request in the mail list to present it in the routing working group, especially why do we need a new model and the implications with the rest of model and the architectural implications. So please, if you can move one more slide. Okay, so I'll go first and try to explain why do we need a network model for VPN service. So we will see how to use it in the different architectures that we have seen, and what is missing in current approaches, and how are we doing this, and which are the open issues. So please go to the next slide. Okay, so first of all, why do we need a network model for the VPN? So we have already a layer 3 service model, the one that is defined in RFC 8299. This model is very nice and describes the service from the customer perspective, and it can be used in the communication between the customer and the network operator. So we think this model is good for that communication. So this does not enter into the discussion of the parameterization of the network resources that you need to orchestrate in the network, and also it does not enter into how the service is mapped inside the operator's network. Okay, so please go ahead. Next slide, please. Okay, can you move one slide?
Yes.
Okay. Okay, so what will be the architecture? So we have taken the pictures from the RFC and map there the different models. So in the general architecture, what we'll have is that the customer, that is the user of the service, can use this L3SM model to communicate with the service orchestration layer in the operator. Okay, so that perfect. We have a working young model for that. And as we said, this model should not care anything about the network resources, even internal routing details. It's just his part uh, of the movie. Okay, so then we have what we call the network model. So this describes the service as perceived by the network. And it's aimed at being as the input to automated tools. So you can do the provisioning, you can do the assurance. So it is a model to be used by network operators. Okay, so this work came as input. So when we started to do our automation in Telefonica and in other service providers, and then when we started looking at the models and try to implement the models is when we discovered that the current existing models were not enough or were not directly aimed at what we needed. Okay, so this model cares about topological details, for example, understands about PEs, and also is able to understand about network resources. For example, the allocation of artists and artists that they do sometimes reside in the OSS layer, so you need to give them as input when you want to create a service, especially when you need to go through multiple domains that you need to preserve some of these parameters across different segments. Then you need to include them in the network model. But those definitely you don't need them for the customer. The customer can forget about them. Also, it is a network model, but as it is aimed at being input to automation tools, it does not detail how the service is transported and also does not detail the node configuration. That is the role of the automated layer to get and translate this model into device configuration. So here also we are assuming that the routing is already configured, so you don't need to do it in advance. We don't enter into that in the model. So also later, this orchestration layer will take care of how to provision the service. If it's needed to set up new LSPs to transport it, okay, he will take care of that. Okay, so next slide, please. So also we can try to map these models in the ACTN architecture. So here, these models in conjunction with other models will be used in the multi-domain service controller part or between the MDSC parent and MDSC child. Okay, so we think there is where the model will apply. Okay, and but not in the device configuration part. Okay, so we leave L3SM between customer and MDSC, and internal in the CNC on between parent and child. So please, you go to next slide. Okay, so what is missing in current service model, and this is the reason why creating the network model. So there are some scenarios where the service model from the customer perspective is not sufficient for the deployment of the service. So we need to identify the provider edge where we are going to deploy the service. Also, we need details about the bidders. So we think that the key are the bidders, that are the physical connections to the PEs. So that is the network element and the port that where the clients are connected. So we need the beer Ethernet encapsulation, and we need also the list of the bidders that are available for each site. Also, we need to, we have cases where we need the remote firing configuration. For example, we have use cases in our operation where we have a pseudo wire stitching to an L3 VPN. Also, we have use cases for multi-domain resource management. So we have to, our VPN is split in several domains. Also, we need some configuration specific to the node. So let's say the equivalent to the BRF that we need to specify from the service definition, and also to cover more routing protocols between C and P. Okay, so next slide, please. Okay, so how do we do it? So we are doing a prune and extend approach. Okay, so we try to preserve as much as possible the structure of the service model, and just to remove what is unnecessary for the network perspective. So everything about customer details and locations, etc., from the customer, we can remove them, and we extend. Extend it to consider more the operator perspective there. So we include the concept of VPN nodes and the peer, and we link them to the peers that are the connections to the VPN nodes. Okay, so I don't want to enter into the details of the model itself. That is for you to read and discuss here, just to present the concept today. Okay, so can you go to the next slide, please? Okay, so what are the open issues? And I think those are the ones that are some of them very related to the previous talk of Dean. So first of all is how to link the network service young module with other modules. So we are assuming that the network automation tool, so some people call it SDN controller, as you want it, there will be set of modules available there, and they need to be linked to each other. For example, topology, the first one. So we assume that the service endpoints or the service or the points from where we want to establish services, they are part of an existing topology. Okay, so we need to link them somehow. For traffic engineering, there is already a proposal in TIAS to be able to map services and also the LSP tunnels that they support them. Okay, so I think this is needs to be completed and brought. Another part is that there is another chance, the composed VPNs, to create more complex VPN scenarios that go beyond the single operator services. Okay. So this is only a few of them. I still think we need to cover, for example, for the assurance scenarios, we need to go also further than this. Also, some open issues is how to deal with the hierarchy of controllers. Okay, so in many cases, we will deal in the reality that each domain or its ISIS domain or its OSPF domain will have its own control. So we need to create a hierarchy. So can we create this model genetic enough so it allows this hierarchy? Also, we have some, as in every you design every young model, we have our own modeling discussions. For example, the set attachments, if they are separate container or part of assigned network access, these are just pure young modeling discussions. Also, for example, the use of profiles versus creating the resources directly under the VPN node concept. So here we have our pros and cons of the reusability, but these are just, I think, minor or more technical discussions and not as general. So for me, the general discussion that I think this is an issue that where IETF and especially routine working group can help is how to link the different young modules together so that they are not separated modules islands, because otherwise it is you have to do hacks or tricks to be able to link them together. Okay, so if you go to just to the final slides.
Sorry about
Yes.
that.
Yeah, the last
Excuse
slide.
me.
Okay, so far received quite good feedback from OPSA working group and F3SM mailing list, and we want feedback on this model. I'll let you know that we also plan to implement and deploy this module in our network in Telefonica and in other operators as well. For example, Vodafone, they are also aim to implement this model in their network. Okay. So thank you very much, and I hope that the remote presentation went well. This is my first time doing this presentation. So open to questions.
Hi, Oscar. This is Igor Briskin. So, just question for clarification. Today we have layer 3 SM model, right? As you mentioned, that allows clients to communicate service to the network. We have numerous models for the network orchestrator, for example, to discover topologies, okay, including multi-domain scenario, setting up tunnels. We are also working on the model that allows steering services, like layer 3 services, to the tunnels, or tunnel pools, or even topologies or slices. So basically, it is not really clear for me what exactly is missing.
Those last pieces of work that you have mentioned are complementary. Okay, so what this complements is the service model. That currently the service model is just created from the perspective of the customer. So, for example, the customer does not see to which specific port it is connected in the network. He does not care. It can go through different switches. It does not know to which encapsulation it is reaching your network. So that you can use it as input, and the operator can decide, okay, based on this service description, I am going to put this customer in this P, and I'm going to put it in this particular port and with this particular encapsulation. So that is not part of the service model, because that is done from his perspective. So this is why it complements the service, the current service model. So it is a description of the service from the network perspective. Okay, so this is why, and the other works that you just mentioned, the steering of the traffic, etc., they are complementary to this one. Okay, and the other things that are missing, they are explained. Also, for example, the L3SM does not have parameters like RTs or RDs that us as operators, when we create a service, we give them today. The L3SM model explicitly says that they do not enter into that resource allocation. So in the network model, as operators, we need to enter into that resource allocation business. So this is why we have to add them to the model.
So, but the client is not expected to get into the network resources, right?
Yes, yes. The client, no, yes, but this model is not aimed at being used by the customer. Okay, the customer
Right.
is so the customer is perfectly fine with using the L3SM model. Okay, so this is from the service orchestration layer or the OSS layer within an operator to the network controller. So this is the particular part of the chain or the tool chain in an operator where we do think this model is needed and where we are going to implement it.
So the network orchestrator takes as an input whatever client communicates over layer 3SM model. And then it uses separate models, right, to discover and basically allocate resources and set up services. Okay. Yep. So we are talking about different models which are all in progress, right? Some of them in tiers, some of them in the service. Right. So basically, from what I hear, there is something missing in terms of for client to discover how their services map to the access points. But beyond that, I don't understand. But we need to talk on the list.
Okay. Yes. Please feel free to comment on the list, and we are happy to clarify there.
And to be clear, that would be in the ops area working group list?
Yeah, so far we are discussing there in Ops Area Working Group list.
Okay, we'll take the last two sets of questions.
Yeah, this is Prakash. I have a question regarding your service model. Is there any dependency on the device model? Because finally the services has to be implemented by the device itself. So do you see a relationship or any dependency on the device model or they are totally independent?
So far, it is independent. Okay, for that, the piece that you are talking would be some service decomposition into device model. So far, it is independent, and I think it should be independent on how you implement it. Okay, so far, independent.
So then assumption is that the service has been implemented by some kind of consistent technology across the devices, like different segment of the networks are being kind of made of the same kind of, or using the same kind of technology, or what's the thought?
Yes, I am assuming that the controller of that portion of the network is able to provide the service based on doing his device configurations. And this model, I don't enter how they should do those configurations.
Could you please repeat your name for the Etherpad? Your name?
This is Prakash from Cisco.
Thank you.
Rob Wilson, Cisco. So I just had one question on your implementation. You say that you prune and extend, and I was wondering about the prune bit, particularly in the case of like hierarchical models, where if you want to have hierarchical controllers, I was wondering whether you need to carry some of the information that's in the L3SM top model further down the stack, and hence whether it should be more extend than prune. But I don't know either of the models, so I don't know what's been pruned.
And so far, let me clarify that we have done the extend, and we have not yet started the prune. Okay, so just when we start the prune, we'll see how much can we remove from the L3SM, or how much do we need to pass from L3SM. I guess all the technical and routine CP part will be kept, and we will just have to remove some of the more commercial related information, or the site related information, which is relevant for the service but not for the network. Okay, so this is next step. There are also some parameters like the grouping that were associated to the client, and that you use them in the service layer or in the service orchestration layer to decide, for example, if you give one or two accesses, or you connect them to separate PEs and so on. So once you have decided that, maybe then they are all not needed. Okay, so the prune part will be next, and these are the kind of things that we are thinking in pruning from the L3SM model.
Okay, I think that makes sense. But one of the questions with the pruning is it may be you want to change information that was mandatory possibly in the top level L3SM model, and then make it optional to potentially be carried through down to the lower level, I can't remember what it's called, the other model, the network model.
Okay,
that might be an option.
Yeah, that can be an option. Just keep it optional, just in case it's needed downside.
Thanks.
Can I make a last very quick comment?
Sure.
Yeah, this is Dhruv from Huawei. I feel this work is quite important because in some implementations, we were seeing people directly converting L3SM model to device model. And because that's the only two models that existed, and not having this network model was creating even a lot of implementation complexity. So we really welcome discussion on this L3SM model. Thank you.
Thank you very much.
Okay, thanks a lot, Oscar. That went very well remotely.
Yeah,
thanks.
thank you.
So next up is Yari Arko.
All right, good morning. This is work that I've done together with Brian, Ted, and Stephen. And it isn't necessarily a new thing, and it's not rocket science, but it's, we think, a change in the environment and the internet environment that causes us to think that this is a topic that should get a little bit more attention now at the IETF and other places. There's a couple of drafts, and there will be after this IETF a few more. You can take a look at these if you like. There's also been some discussion at the recent IAB workshop on deployment expectations and versus reality workshop. Happened in Finland at the beginning of June. And at this IETF, we'll have a discussion at the security area group on Thursday, I think. And so there's this RFC 3552 that is guidelines for writing security consideration sections on RFCs, which basically all of us follow, try and figure out what kinds of security things we need to consider and describe in our RFCs. And one of the sections there, I think section 3 possibly, is about the internet threat model, and basically tries to describe, this is the environment that we should prepare for and defend against, or defend against the bad things in the environment. And it says, first of all, that we assume that the attacker has complete control of the communications channel that our systems are communicating in. And that's obviously still valid. There can be attackers in our environment, and we've been making some progress, I think, recently on encrypting more traffic and using more encryption and cryptographic mechanisms to protect our communications, and that's great. But it also says that we assume that the end systems engaging in protocol exchange have not themselves been compromised. So basically assuming that, well, outsiders are bad, insiders are good, and that's the assumption that we build protocols for and try to describe how they manage in that situation. And basically the belief is that changing my screen here. Okay. So we believe that protecting the communication is still very much necessary, and we probably need to be doing it better than we're doing today. There's some improvements that are useful there. But we are sort of doubting this second part of this assumption in this RFC. It seems to be basically counter to current reality. So, and there's a couple of reasons for that. We've, as I said, made some progress in encrypting internet traffic. I think, at least from some networks that I follow, we went from, say, 20% encrypted traffic to 80% and are headed towards 100. So that means that if you were previously spying on stuff by attaching a sniffer on the network and looking at the packets, that is no longer possible as easily. And if you are a determined attacker, criminal or governmental or surveillance or whatnot, you will think about other options. So you will look elsewhere now. And we've seen some of this actually. There's been government surveillance agencies who are today more focused on acquiring data from, say, a content provider than from looking at, what's going on in the wire or the wireless domain, for that matter. There was a case of Australian proposal for a law, which I think actually came to be a law, about what they can, try and force various internet entities to provide for them, and this is sort of to the heart of that desire by some surveillance agencies. There's also surveillance in a commercial sense, surveillance capitalism, as they call it, and there's new risks for us, the users, because some applications are having, far more data collection than they perhaps did in the past. So information about us or our activities are being collected. There's very big databases being created, perhaps as part of the first item here. And there's a fairly common design pattern for building network things where you have centralized parties that are controlling other entities, and that if I want to communicate with my friend, first I go to the cloud, and then the cloud communicates back to my friend. That design pattern is almost universal today. There's also a fundamental issue that the interest of a party that you communicate with is not aligned with your interests in all cases. So you might be, fully encrypted and protected and authenticated, but the entity at the other end of the tunnel might not be having your best interests in mind. So let's say a social network or some such. There's also the question, when we consider compromised nodes and things that can happen, that like a network that you thought that was not connected to the internet or wasn't interesting from a vulnerability or attack perspective actually turns out to be attackable. A little bit more on that later. So I have some descriptions of this. I won't read the poems that my colleagues wrote about this topic. I'll just let you read them yourself. This person one, sort of a depressing worldview kind of poetry. And there's also more prose-like approach to this, describing the situation. So basically, we assume that applications, either on our end or the other end, may themselves be working for adversary, or maybe on a network with other endpoints hostile to our interests or the application's interests. And that's sort of breaking what the RFC said earlier. So the question is, what do we do? So the four of us who've been thinking about this, we've been writing some things and talking about it. We happen to be on the IAB, at least for now, the four of us, but it's not an IAB thing at the moment. It's a personal thing that we're trying to discuss. At this IETF, basically, we're just sort of calling for interest and discussion and get some guidance and feedback. If you think we're crazy, or we should do something else, or we should adjust this or that way, please tell us. And you might also say that, yeah, that's all true, but there's nothing that we can do. We just built a communications pipe. It's not our problem. There's some truth to that, but there are also some useful things that we could do. One example is obviously data minimization, that we should think more about that. Like, what do we actually communicate in our protocols and systems? We should maybe avoid creating new centralized architectures. And everybody can think of some examples, maybe some recent examples, perhaps from the DNS space, for instance, where that's been the case. There's also other things like protocol things or cryptographic things, like trying to keep things as modular and separated from other things as possible. So perfect forward secrecy is one such example. I've been working on one protocol, for instance, where we tried to make it PFS capable today, even though it was designed as not such a protocol many years ago. And the reason for that is that if something leaks or some node gets compromised, then you don't want to lose all the communications in the past and in the future, but you actually have some compartments. And another example that's not on the slide, I've been working quite a bit with 5G, and it has many really good improvements over previous generations of systems, and not just in speed and latency, but also in security. One of those improvements is identity privacy, that the identity of the end users is not visible to others. So it's pretty secure from that perspective. So it's not visible to others, sort of like looking at the radio traffic. But internally in the networks of course still have to know who this is for billing reasons and other reasons. But if you look at the network design, the details of that, the real identity of an or the real phone number of a device is actually revealed to fairly large number of devices in the network, which if we redesign things now, maybe that would be something that we should look at and reduce the number of entities that hear about this particular piece of interesting privacy-related information. Just keep it on a need-to-know basis. So that's the kind of example that we can do in this space. And also, when you do your security considerations or design new architectures or protocols, do think about the abuse cases and not just the use cases. Like, what if somebody compromised this node, what would happen? Or what if somebody made this a centralized architecture and collected information? What would it look like? And see if we can actually defend against it. The RFC with security considerations guidelines, possibly we might update that later, or we write some other RFC about this topic. We're not there yet. We're just discussing. For now, we're probably going to create a mailing list and talk about this topic. I wanted to sort of briefly go into like why I'm here and how it might impact network operator situations. For instance, I did want to say, I didn't have it on my slides, but if if you look at my draft, there's a bunch of guidelines, and I just want to sort of briefly mention a few of them. So starts with considering the first principles in communication or protecting communications. That like if you perform something via some node instead of going directly from your friend from you to your friend, then that means that if you want to protect the communications against others, then maybe you should protect them not just hop by hop to the node in the middle and then back to your friend, but all the way, so end-to-end protection. So this means that you have to think about things not just in terms of, we just use TLS and just stick it in and then everything's going to be fine. But you actually have to think about like what are you doing and what are you trying to protect from. Want to minimize information passed to others, want to minimize passing control functions to others. Well, we do a lot of that in the operator networks. Want to avoid centralized resources. Or at least you need to be aware of the risks of centralized resources and controls. Anyway, so operator networks. So a lot of this work has been inspired by sort of like end user internet views, like how do we leak information from individuals to large entities from the other side of the world. And that's not really the problem that we have with network operators, but they also have large networks, and their problem is slightly easier because you don't necessarily have to worry about the interest misalignment that you have to worry about in a lot of other cases. So all your things are sort of under one control, one ownership, perhaps one network manager. But even in a closed or one network owned by one party, there is a lot of potential for being vulnerable. So if you think your nodes are under your control, you haven't been reading enough documentation about attacks on Intel CPUs and such. So there's plenty of opportunities for nodes to become compromised. And I think we should assume that entities like this can be compromised in all kinds of networks and design architectures with that in mind. Doesn't mean that you can't have your nice control node in the middle of the network, but it does mean that you should understand the implications of what happens if this thing goes down or if this thing gets compromised in some fashion. And of course, that's in the most general sense, that's probably an unsolvable problem, Byzantine generals or Byzantine routers, but I do believe that it deserves some further thought. So that's what I have today, and be eager to discuss or take feedback or have people join the thinking team. Thanks.
Any questions for that?
So VRA, just to recognize Frank Bruckner's, I think this is useful despite the fact nobody stood up. And I think we have to get ready for a world where we may only want to go and trust devices that convey trust along with what they're sending. So maybe we just mistrust everything, and then not like we have today where we believe everything behaves. And maybe tomorrow we believe that nothing behaves unless it's proven that it behaves. And I think this is steering that direction so that you're reversing the logic of what we believe an equipment does today. And I think it's useful to go and look at that, what we can do, whether we can have information conveyed along with the operation that this device can be trusted, and as such. And then intrusion and then compromise could be slight misbehavior, right? I queue your messages a little longer than mine, so that in a financial transaction, you lose, I win, right? So it's not massive necessarily.
Thank you. And yes, I agree. And yeah, I mean, one thing to say is that there isn't necessarily a solution for all of this, but it's still, I think, important to be aware of this and understand our risks and manage those risks. Anything else, or are we done?
They say you cannot be paranoid enough.
Yeah.
Thank you, Eric.
All right, thanks.
So, sorry, this is Adrian Farrell. It's all right, Yari, you don't have to come back because I'm targeting Frank. I don't think you can approach this, because of that last line, Byzantine routers are hard. You can't approach this by saying, I won't trust a node unless I can prove it works, because there's a sociopathic principle there that the node will prove that it's okay until such time as you trust it. Yeah, so you can't establish that anything is trustable.
Thank you, everyone, and we'll see you in Singapore.